All right, Algebra 2 students, we're back in our absolute value syllabus. Working on Tier 3, we are now on Lesson 5, which is, again, combining all absolute value transformations. So let's check it off. So here in Lesson 5 on Tier 3, we are given a graph and its parent functions with multiple transformations. List all the transformations in correct order. Now, one thing I did to be kind of nice is I didn't do any compressions because those are sometimes hard to see on such a small graph. So I'll give you that hint, but you gotta come back up here to the steps of multiple transformations, and you gotta go in order again. So we gotta look horizontal. I told you there's no stretching or shrinking. We gotta look for reflection and then vertical. So horizontal, reflecting, vertical, because I told you there's no stretching or shrinking. So horizontal, you can see we definitely went this way 4 units left. And then if we look, the next thing is a reflection, and we definitely see that we reflected over the x-axis. So we definitely have a vertical reflection from here to down. We have a vertical reflection. And then lastly, we look at the outside stuff, or the vertical transformations, and we can tell that, let me erase this so we can see. We can tell that we started at 0 and we went to -2. So we went down 2 units. And now we can use this information to write an equation for this transformation, for this function. So we know that our parent function is f of x equals the absolute value of x. And we know that we went 4 units to the left, and we know that anything that deals with the horizontal is on the inside of the absolute value expression. So we know for sure that if we have an absolute value expression, we're going to put our x in here, it went left 4 units. So that goes on the inside too. But if it goes left, remember it's opposite of what you think. So it's not -4, it's +4. Cool, that's the first part. Check that off. We're done with it. Now, the second part, we know we have a vertical reflection. It flips upside down. So then we know that all we have to do to create a vertical reflection, because I already told you that I didn't put stretches in here for you, our compressions, we have to put a negative in front of the absolute value expression. So our vertical reflection component's done. And then lastly, we do the vertical transformation or shift, however you want to call it. And we notice that right here it was down 2. And that goes on the outside because it's vertical. Anything that deals with vertical goes on the outside. And that one is just -2. So here we have it. By recognizing all 3 in order of our transformations, we are able to take the parent function and create the shifted or translated or transformed function.